Today we are doing Eureka Math, Module 5, Lesson 4, and our learning goal by the end of our lesson today, you should be able to use multiplication to calculate volume. And not only do that, but explain why the multiplication sentence works to calculate the volume of a rectangular prism, okay? To warm up our brains, though, we're going to talk about this problem of the day problem that actually came from the homework of yesterday's lesson, because this is something I think we need a little bit more help in. Here I have a rectangular prism. I know it is a rectangular prism because it's 3D, right? This is the front face, and every single face is a rectangle. Do you guys see that? And it tells us the measurements. It tells me that the length is 3 centimeters. Do you see that? 1, 2, and 3. Do you guys see that? Okay. The width is 2. Do you guys see that the width is 2? And the height is 4. Okay, go ahead and draw this prism into your notebook. Based on what we know from yesterday, we can cut this into layers in a number of ways, right? We can cut it, hold on, pause for a second. We could split up the height, right? How tall is my figure? 4 centimeters tall. So I could cut it like this. 1, 2, 3. Split up the height. Do you guys see that? If I did that, how many layers would there be? 4 layers, right? 1, 2, 3, 4. And if I did that, how many cubes are in the top layer? Well, how many are in this front part? 3. And how many are in the back part? So altogether, how many are in each layer? 6, right? We can also see that in that case, there are 4 layers. That's what we just said. And to find out how many cubes, there's 3 times 2. 3 times 2, which is 6, right? Do you guys see that? So altogether, we know that's 6, right? So how many cubes would there be altogether? Well, there's 6 plus 6 plus 6 plus 6. 6 plus 6 plus 6 plus 6, or 6 times 4. How many cubes is that altogether? 24. Is that the only way we can cut it into layers? No. We can also split it by the length. We could say, cut it here and cut it here. Right? Cut it here and cut it here. Do you see how that's the same thing? If I did that, how many layers would there be? 3 layers. Okay, how many are in each layer? Well, there's 4 here and 4 here. Do you guys see that? So how many are there in each layer? 8. 8 and 8. Did you guys see how that's 2 times 4? 2 times 4, which is 8. You guys see that? So there's 8 plus 8 plus 8. How many cubes is that all together? 24. The volume is 24 cubic centimeters. Okay, I can also split it by its width. I could cut it like this. Like this. Do you guys see that? If I do that, how many layers are there? 2. There's a front layer and a back layer. You guys see that? How many are in the front layer? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 in the front layer. And then how many are in the back layer? 12. Is that the same thing as 3 times 4? Yes. 3 times 4 equals 12. So there's 12 in the front and 12 in the back. How many cubes are there all together? 24. Very good. Do you see how when we want to find the number of cubes in each layer, it's like finding the area of that layer. For example, this bottom layer right here, in order to find how many cubes are in that blue layer now, we have to do 3 times 2. Isn't that like finding the area of that layer? 3 times 2. And then once we have that, we know we have to multiply that by 4 because there's 4 of those layers. Do you guys see that? So in order to find the volume, we could find the number of cubes in each layer, which is 3 times 2, or what? 6, and then multiply that by 4. What's 6 times 4? The volume is 24 cubic centimeters. Same thing over here. If I want to find how many cubes are in this layer right here, right? I find the volume, the area of that section, which is 2 times 4. Do you guys see that? Right? Because I would do 2 times 4, which is 8. And then how many times do I have? 8. So I do 8 times 3. So 2 times 4 to find how many cubes are in that layer, which is 8. And then times 3, which is? Does that make sense? Talk at your table. How does that repeated logic apply to this last slicing here? Are you guys seeing that we can find the volume by multiplying the length times the width times the height? Are you guys seeing that? The length times the width, what does that tell you? That tells you how many cubes there are in one layer. The height is how many layers there are. Do you guys see that? So the length times the width will tell you how many cubes there are in each layer. And you multiply that by the height because that tells you how many layers there are. And that will tell you how many cubes there would be all together. Does that make sense? Give me a thumbs up if that makes sense. Okay, let's see if we can apply this to more problems. So just like in the previous example, we remember that for these measurements, length, width, and height, we're just finding a distance, right? We're finding the distance between one point to another point. So those are regular units. Do you guys agree? Okay. So what's the length of this prism? 1, 2, 3, 4. 4 centimeters. Yes? Okay, what's the width of this figure? 2 centimeters. Good. What's the height of this prism? 4 centimeters. Very good. So what's a multiplication sentence we could use, including the units, to find the volume? Well, we know the volume, V stands for volume. If I want to find the number of cubes in one layer, and I split it like this, how could I find the number of cubes in this bottom layer? Well, I could do 2 centimeters for the width, right, times 4 centimeters for the length. Do you guys agree? How many cubes are in this bottom layer? 8 cubes, right? How many cubes are in this next layer? 8 cubes. How many cubes are in this next layer? In the top layer? So therefore, I could do 8, which is 2 times 4, right? And I can multiply that by the height, which is 4 centimeters. Do you guys see how that works? Okay, so this is taking the logic we just talked about with the layers and turning it into a multiplication sentence. So this is an example of what a multiplication sentence would look like that includes units. Do you see how each measurement has its units? Okay, good. Now let's multiply. What's 2 times 4? Times 4. 32. So how many blocks, how many cubes are there in this prism altogether? 32 blocks, right? 32 cubes. What is the volume? 32 cubes. Right. 32 cubic centimeters. So remember, distinguish between the difference of asking how many cubes there are versus what is the volume. There's 32 cubes, but the volume is 32 cubic centimeters. In order to find the bottom layer, so to speak, we can imagine that there is a bottom layer there. Do you guys agree? How can I find the area of that bottom layer? Everyone? 8 inches times 4 inches. Don't forget to include the units. So what's the area of that bottom layer? 32 square inches, right? Good. But how many layers of that 32 square inches do we have? 8. So then I have to take 32 square inches times 8 inches. I don't know how to do 32 times 8 in my head. Does that mean I can't do this problem? It means I need to do what? Standard algorithm. Good. So 32 times 8. What's 8 times 2? Good. What's 8 times 3? Plus 1. So what's the answer? Cubic inches. Good. So just look carefully to see what the units are. So do you see how even though now we don't have cubes, it's the same reasoning. We find the area of the bottom, which is length times width, and then we multiply it by the number of layers of that area we would have, which is 8 inches, the height. Make sense?